from s orbital shifted to d orbital in order to attain this stable electron configuration. Why? For example, if I talk about this 111 element with atomic number 111, so this is 86 add-on 7s2 5s14 and then 6d9. So instead of 6d9, because d orbital when it is half filled or fully filled is more stable. So when it is going to have 4 electrons, 1 2 3 4. So when it is going to have 4, it wants to have 5, so it will borrow. If s is going to have 2 electrons, 1 electron will jump into this one. It will borrow 1 electron and will have the electronic configuration like this, because half filled d orbital is more stable. And similarly, if it is going to have 9 electrons, okay, then it will again borrow the 1 in order to have 10. Got it? So what would happen? 86 Rn, this will be 7s1 and then 5d14 and then 6d10. 6d10 will be there. Okay, got it?
Yes.
Note it down. Similarly, in 46, what happens? The atomic number is 46. 46 is 36 krypton. Okay, 36 krypton. And then it is going to have 36. So 36 is krypton, then 5 s2 and then 4d10. 4d8. The electronic configuration should be 5s2 38. Okay, and then 4d8. Okay, then it is 46 total. But actually this is not so. What happened in order to attain stability? This krypton, this 46, this is going to have electronic configuration. S will donate its 2 electron to both of it and will become 0 and will become 3d10. Here it is actually 8. Are you getting? But no join. No. Done? Noted?
Yes.
So tell me, what is the electronic configuration of an element having atomic number 57? Atomic number of element is 57. What are we going to have the electronic configuration? Tell me fast. $57. So 54 is the atomic number of xenon. Okay. Xenon 54. Then in which orbit it is
5d1.
6s2 and this is 50. 46. Okay. 54. And then it is going to have 5d1. Okay. So what it is going to have is 5d1. But it also have 4f. Okay. 4f1 and 5d0. But in order to attain stability, this 57 is exception here. What does it do? Xenon is going to have 6s2, then 4f0, 1, I'm writing 10 here. That is going to have 0, and then it is going to have 5d1. So this is the correct, means from sf orbital, the electron jumps into the d. Got it?
Yes.
There are some exceptions in this one, like in 24 also. Here you can do the electronic configuration. Tell me, what is the electronic configuration of this one? Tell me.
One S2.
This is 24.
Yes.
Then is the 18.
Yes.
18. Then argon is the third period. The third period is over. Then fourth period will start. 4s2. Then argon is the third noble gas. You need to remember the name of the helium is in first. Then neon. Then argon. Okay. Then krypton. Then xenon. Then radon. Okay. So this one. This is you have to remember. So this is in third period. So after this one, fourth S2 will start. Okay. After this is 5s2 will start. After this 6s2 will start. After this 7s2 will start. Okay. Got it?
Yes.
So what's the electronic configuration? F is not there. In 6th and 7th, we are going to have F. F. So okay. So if it is 6F, 6s2, then 4F orbital will be there. If this is 7F, 7s2, then 5F2 or 5F orbital will be there. Okay. Got it? What is the number
Yes.
of this one? If it is N is S, then N minus 2 will be the F and N minus 1 will be the D. Got it? So this is 20. Then it should be 3D, 3D4, but it is not so. In order to attain the stable electronic configuration, okay, the fourth, it want to be half filled. So from S2, the one electron will jump to this one. Okay, will jump to this one. So this is 18 argon 4s1, then 3d5. Okay, this is the correct one. Got it?
Yes.
The general electronic configuration of D block element is NS0, 1, 2, and N minus 1, D 1s to 10. Okay, means it can have 0, it can have 1, it can have 2. Journal is this one. Okay, and or we can say that N plus 1 S 0, 1, 2, and then N D 1 to 10. Okay, this can be also written. Got it?
Yes.
Now group wise general electronic configuration. If I talk about group wise general electronic configuration. That is for the third shell. Third shell, it is going to have NS2 bracket N minus 1 into D. Okay. D1. If I'm talking about the group. Okay. Along the group. Got it? So for talking about the third group is going to have NS2, N D1 will be there. Okay. The fourth group is going to have NS2, N minus 1, and then D2. The fifth group is going to have NS2 bracket mein N minus 1. Okay, then D3. Then sixth group is going to have NS it will be ns1. 6 will be, because 4 is not there. Okay, so it will be ns1 and then n minus 1 into d raised 5. Okay, got it? Then 7th group
Yeah.
is going to have ns2 n minus 1 and then d5. And 8th group is going to have ns2 n minus 1 then d6. Okay, then 10th group, sorry, 9th group. 9th group is going to have ns2 bracket n minus 1 d7. Then 10th group ns2 bracket n minus 1 d8. Okay, but there is an exception. D8 was not there in case of that we were discussing 57, 46. Okay, so here similarly in the 11th group it will be ns, then again 9 will not be there, this will be n minus 1 into d10. Okay, then in the 12th group it is going to have ns2 bracket n minus 1 into d10. Okay, got it?
Yes.
Now talking about the volatile metals. Noted this one?
Yes.
Volatile metals. So when I talk about the volatile metals, we have zinc, cadmium, mercury. Zinc, cadmium, and mercury are considered to be as volatile metals. Coins metals are copper, silver, gold are coins metals. They are all D block elements. Okay. Got it? Got it?
Yes.
So in D block elements, in if I talk about the D block, in D block elements, okay. The outer, for example, if I'm saying 4s2 3d5, okay. So this is the outermost shell, okay. And this is going to have 5 electrons. This is the inner. Okay, so if I talk about that in D block elements, the number of electrons present in the outermost shell, number of electron present in the outermost shell is 1 or 2. Got it? But the number of electron present in the or we can say penultimate shell. Okay, penultimate shell. Then it is from 9 to 18. Got it? Got it?
Yes.
For example, the maximum electron it can have is 9 to 18. Okay. For example, if I'm having the electronic configuration of chromium 24. Okay. So it is going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d5. Okay. 4s1, 3d5. 4s1, 3d5. Okay. So the fourth shell is going to have 1 electron only. And in the penultimate shell, means the third shell, the previous to the outermost shell is going to have 3s2, means 2 electron of 3s2, 3 electrons of this one. So 8 will be completed here. And if it is going to have 1 in 3d5, okay, if it is 3d1, then it can have 9. If it is going to have 3d2, then it will have, means it will have 9 to 18 electrons. Okay, got it? So this is
Yes.
3D is going to have 1 to 10. So here 2, 6, 8 is common. If it is going to have 1, then it will be 9. If it is going to have 2, then it will be 10. So 9 to 18 electron is going to have. Okay. You understood?
Yes.
But the outermost shell, yeah, outermost shell, we are going to have S here. But actually, the electrons after the S start filling in this one, so it is considered to be as D block element. Okay. Got it?
Yes.
But here is an exception that in palladium, palladium is going to have outermost shell's electrons is 18. That is an exception that we're going to have. So PD, in PD, the outermost shells have 18 electrons because palladium is going to have atomic number 46. Okay. And then 36. Okay. Got it? Krypton. And then after this one, or we can say krypton 36. Then what's the electronic configuration of this one? 36 is done. Then 4 is sorry. How which orbits we're going to have? 5s2. 5s2. Then the fifth guess. Neon, helium, neon, argon, krypton. So it is the fourth one. So we're going to have 1, 2, 3, 4. Okay. So after the fourth, it is going to have 46. Okay. So this is going to have fifth shell. It belongs to the fifth. Means this is krypton is going to be somewhere here. This is the fifth orbit because this is the fourth orbit is being completed here. Okay. So 5s2, then 4d. How many remaining? 38 has been done. Then how many are remaining? Tell me. Tell me. It should be 8.
Yes.
But it is an exception that 36 is going to krypton. Okay, then it will going to have 5s0 and then 3d10. Then 4d 10. But since F is not, S is the outermost shell, S is going to have 0 electrons. So this will become the outermost shell now. Okay. Okay. Got it?
Yes.
So 4s2 and 4p6 will be before this one, 3d10. Okay. So they were completely filled. So 8 from this one and 4d10. Then fourth orbit will be considered as the outermost shell for this one because F is going to be 0. Yeah. That's why we'll consider this one. Okay. You understood? And 8, because before 4d10 is completely filled, here the 4s2 and 4p6 was already filled. So the fourth shell is going to have 4s2 electrons, 4p6 and 4d10. So here it is going to have 18 electrons. So this is not exception for the palladium. Understood?
Yes.
Okay. Now talking to the F block elements. Elements in which the last electron enters in the F subshells is known as F block elements. F block elements. And there are two series of F block elements. There are how many series? Tell me. Two series. One is lengthenite series and another one is actinide series. So there are two series. There are two series of F block elements. Okay. Okay. One is lengthenite series, and another one is actinoid series. So please note it down. I will be coming back because there is a voice is coming background noise. So just I'm going to love the curtains. I will be coming back in 1 minute. Okay. Done? Noted this.
Yes.
So lengthenoid series is a series that start that is going to have F block element. Actually, lengthenum is not considered as a F block element. This is the upper element. After the lengthenum, the elements are there and they are considered to be as lengthenoid series. Lengthenoid is actually itself a D block elements. Okay, got it?
Yes.
Here is this is from 58. Lengthenum is 57. From 58 cesium to lawrencium. Lu. We are going to have from cesium to cellurium, not cesium. Cellurium. Okay, so it is 54 Xe 6s2 4f1 and then 5d1. Okay, and this is 54 Xe 6s2 4f14 and then 5d1. So they are going to have d1 because they are all cesium to this one. They are going to have d1 because they are present at the same place. This is in the drawers. All the elements, all the 14 elements are placed at the same place, like in the drawer. Okay, got it? This is lengthenoid. This is, and this is inside the lengthenoid is cellurium. Then till lawrencium, they are present in the same group. And in the lower one, we are going to have the, so since they are present on the uh, third group, it is on the third group, they are present. So that's why they're going to have 5d1. Got it?
Yes.
Got it? All of them are going to have 5d1. Next is, and there is an exception. Okay, let it be. Next is, if you are going to have that, they are also called, the block elements, one times they are also called rare elements. Okay, rare earth rare element because they are rarely found. Okay, so we can say that they were earlier called, they were earlier called rare earth method, rare earth metals. Got it?
Yes.
Okay, now moving to the next one is at present. And at present, they are called lengthenon. Are called lengthenon. Okay. Got it? Next one is, if I'm talking about the next one is abnormal electron configuration in F block element, there is also abnormality in the F block element. So abnormal electronic configuration in F block elements, in F block elements. First one is atomic number, in atomic number 48, 58 and 64 and 57 and 89. They are going to have some problems. So let's talk about this one. The next one is in atomic number like 58 and 64. Okay, let's take 64. 54 and then XC in 54. XC the fifth novel gas. This is 6s2. Then n minus 2 is 4. Here should be D. Okay, so it should be 5d0. Okay, and 4f8. In 64, there should be 5d0. D should not be there. 4f8. But here, what happened here is actually it is x6s2 4f7 and this is 5d1. Okay, so this is an exception in 64. Okay, electron from f orbital jumps to d orbital. Okay, in the d1, in the d there was from s8 it was jumping to d. Okay, got it? Here from f it is
Yes.
jumping to d. Are you getting?
Yes.
Okay, the next one is, if I'm talking about the actinoid series, this is an exception, and similarly exception is in 58 also. You can check it there. Next one is actinoid series. Actinoid series. Okay, actinoid reaction, last electrons enter, electrons enters in 5f, because it's the seventh period, so it will be fifth f orbital will be there. Okay, s orbital will be 7, d orbital will be 6, this will be fifth. Okay, f will be fifth. So if I'm talking about this one, that last electron will enter into fifth subshells. Okay, and there are how many elements are there? There are 11 elements. Okay, so there are 11 elements. Total are 14. Total are 14 we are talking about, but the 11 elements after uranium having atomic number, because it is talking after uranium. Okay, so after this one means 92 is this one, so 93 from atomic number 93 to 103 are known as transuranic element. Okay, are known as transuranic elements. Got it? Got it?
Yes.
If I talk about that, they are all radioactive. All the seventh block elements are radioactive. Okay, except the noble gases we're talking about. Okay, so we talking about this one, that all are radioactive, means they easily, means they continuously loses electrons and show photoelectric effect. They are all radioactive. All are radioactive. Okay, journal, if I talk about journal electronic configuration of f block element is ns2 bracket n minus 1 d 0 and 1 n minus 2 bracket f 1 to 14. Got it? Got it?
Yes.
The next one is, or you can say here that it is n plus 2, then it will be n plus 1, and this is n. Okay, so you can have like this way, where n is 6 or 7, because they belong to 6 and 7 period only. Okay, got it? Are you writing or taking a screenshot?
Right. And
Okay. So, Zabdullah Ashraf. Done, noted?
yes.
Okay. Next, if I'm talking about this one is position of F block element in the periodic table. So, let's wait a minute. So now you have done that, all the radioactive elements, these are all radioactive elements. These F block elements are considered to be as radioactive elements. Okay. And if I'm talking about this, there are two series. One is the lanthanoid series and the another one is the actinide series. Both lanthanoid and actinides belong to D block element. They are not actually the part of the F and D block elements. Okay. Got it?
Yes.
And how many total elements are there in F block elements?
11.
Not 11. After the 11 means 11 elements are known as, we are talking about the those elements that are after the uranium. They are known as transuranic element. Transuranic. Okay, and these are the 11. But total, they are the how many electrons are there in f orbitals? Can have is 14. So it 14 in the first row and 14 in the second row. So they are 28 elements. Okay, got it?
Yes.
20. Okay, in the sixth period, 14. In the next sixth period, is again 14. Okay, let's move further. Position of F block element in the period. So if I talk about that, is the second. If I talk about that 3B, 3B means, or we can say the third. Okay, with third A was the 13 period, and third B was in the classification was actually the third period. Okay, these are the third, fourth B is fourth B, fifth B, like this. Okay, so if I talk about that in the third B, okay, so the third B elements is first is scandium. Okay, 21. Then helium at 39 is helium, and then lanthanum 57, and then 89 is actinoid. So if I'm talking about this one, okay, so here they are lying here from 58 to 71, and from 90 to 103. Okay, now 72 is hafnium, HF hafnium, and 104 is radon, RF. Okay, so if I'm talking about this one, so this is 72. So 72 lie in the fourth B. Fourth B. Just we can say that these all are present, okay, in the same third period. In the fourth period, we're going to have 72. And then we have sixth period, then seventh, sorry, fifth period, then sixth period, then seventh period. So are you getting my point that where they lie?
Yes.
So if I talk about that, they will lie. If I talk about that, in which group they are going to lie? So they are going to lie in this drawer, and this drawer lie in the third period. Okay, so when you open this drawer outside, you will imagine that there is a drawer and where these elements are placed in the same. So the group is 3. Okay, and this is 3B. And the period is 6 and 7. Got it?
Yes.
Okay. Next is if I talk about that, which is the largest group that is going to have the maximum number of electrons, sorry, maximum number of elements. We have studied that the sixth group is the largest group. Sorry, period. If I talk about the period, the sixth period is going to have the maximum number of electron, and that is going to have 32. Okay, sixth period. We have the very short period, that is first period, then short period, the 2 periods were short, that is going to have 8. Then long period, Okay, that there were two long periods, then we're going to have very long periods. Okay, so there were two very long periods. So if I'm talking about this one, that period is going to 6 period is going to have the maximum number of electrons. But if I talk about the group, okay, group. So you will find that the first group is going to have seven element. First group 7. Second is also going to have it is not going to have it starts from hydrogen, then helium, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So it is going to have 3, 3, 6, and 1, 7. Okay, and this is going to have beryllium, magnesium, calcium, okay, strontium, barium, radium. Okay, so this is they are going to have this type. But if I talk about that, the third period start is still from this one. Okay, it is going to start from scandium. Okay, then scandium is going to, this is 20, this is 21. Okay, scandium, then helium, then it is going to have lanthanum, and this lanthanum is also going to have plus 14 F block element in the same period. This is going to have a drawer. So 1, 2, 3. Okay, are you getting my point? Are you getting?
Yes.
So, and it is also going to have 89 actinoid, and actinoid plus in the blower one we're going to have actinoid and plus 14 element of this one also. So 1, 2, 3, 4, 4 plus 14 plus 14, 32. Okay, so 4 plus 4 plus 28, it is going to have 32 elements. So this is the only group that is going to have the maximum number of element. Understood?
Yes.
So third group has maximum number of elements. Next, if I talk about that, the F block elements are situated at the bottom. Means they are situated at the bottom of the table due to the means there are some reason that why we cannot place them, why we have the separate two lines in the bottom. So we'll see that these elements have similar chemical properties, and they have if you place them, means these all elements are going to have the similar chemical properties almost. Okay, so if you place them like this, so if you place like this, so they will not going to, means the element that are going to have the same chemical property should lie in the same group. So in order to maintain their same group, okay, and to minimize the size of the periodic table, we just place them in the two separate lines. Okay, got it?
Yes.
Next is, okay, now we're talking about the classification of elements on the basis of their properties. Classification of elements on the basis of their properties. Okay, so first, if I talk about the non-metals, we have divided the metals into three parts, table elements into three parts. One is metals, the second one is non-metals, then metals, and the last one is metalloids. Metalloids are the element that is going to have the same chemical properties of both metals and non-metals. Okay, got it?
Yes.
That's like silicon, germanium, antimony, tellurium. These elements are considered to be as in this table these are considered to be as no metalloid. These are the metalloids. Okay, these are the metalloids. PO and AT are at the same position. Here, if any element is present here, so this is non-metals. So here will be the non-metal area, non-metal. And if any element is present here, it will be considered as metals. Okay, so this is the non-metals area. Okay, this is the metals. But this is actually metalloids. Metalloids. Okay, got it?
Yes.
Note it down. Note it fast.
Done.
Okay. Then name any 5 non-metals, please. Name any 5 non-metals.
Hydrogen, helium, nitrogen, oxygen.
Yes. So if I talk about that, about the non-metals, the non-metals can be any. Okay. So in the periodic tables, non-metals are situated on the left side or the right side? Tell me. In the periodic table, non-metals are situated on the right side or the left side? Nina, tell me.
Right.
They are present on the right hand side. Okay. Okay. So they are present on the right hand side. Metals are present on the left hand side. And in the between, we are going to have an extreme right. We are going to have the noble gases. Okay. Which are also considered to be as, means we don't consider them as metals or non-metals. Okay. They are separated. Okay. If I talk about the P block elements, are you there?
Yes.
Okay. So P block elements contain all type of elements, means they contain metals, non-metals, and metalloids. Okay. P block elements contain all types of elements. Okay, like metals, aluminium. Okay, and non-metals, they have like fluorine, chlorine, bromine, iodine. Okay, and metalloids. Metalloids are all present in the P block element that we have written in the previous portion. Okay, and metalloids. So they are all present in the P block elements. Got it?
Yes.
We have also classified the all elements on the basis of their physical properties, like in the liquid state, like in the solid state. Okay, like in the, so on the basis of physical state. Okay, like we have monatomic gases. Okay, gas, then we have liquids, and then we have solids. Okay, so if I talk about that, Gases are generally means like the noble gases we have and the diatomic gases. Okay, monoatomic atomic gas like helium, neon, argon, krypton, okay, xenon. And if I talk about the diatomic gas like H2, N2, O2, okay, F2, Cl2. Liquids is mercury, cesium, francium, gallium, Hg, and Br2. Okay. Cesium and galliums have very low melting point. They even melt at the low temperatures. They are considered to be as liquid because they generally, if you heat them, means at room temperature, they are going to have, means if even they kept on the palm, they get melted. So gallium and cesium and francium, they have very low melting point. They can easily melt. Okay. So these are metals. These are metals, and this Br2 is the only non-metals. Is the only non-metal which is liquid at room temperature. Okay, got it. And rest of the elements are
Yes.
solids. If I talk about rest elements that are remaining either from metals, non-metals, or metallite, they are solids. Okay. These elements are going to have very low temperature, low melting point. Cesium, francium, mercury is already liquid at room temperature. Okay, even at 0 degree temperature, it is mercury. Got it? So in
Yes.
next class, we're going to start the Neal-Bohr classification of inert gases. And this is an important one. Okay, Neal-Bohr classification. And since Noha is absent today because of some functions in her school, okay, and the important topic is going on, so we'll going to have this class for 1 hour today. We'll give you extra time and she will be there, okay, because otherwise we need to give the backup for this one. Okay, so don't mind, we are just giving. So this is the right topic. Near-Bohr classification we're going to study in the next class. Okay, got it?
Yes.
So that's all for today. I hope you enjoy the class. We'll meet you in the next one.